schedule. Okay. So what was the topic we were discussing yesterday?
Non-experimental design, sir.
Okay, good.
In that one short case study, one group pretest and post-test design.
Good.
One shot have take static group comparison, sir.
Static group comparison. Okay. So what is the main difference between experimental and non-experimental?
In non-experimental, randomization is not there, sir. Only X and O is there.
Good. Excellent. So what X means?
Independent variable, sir. O
Good.
means observation.
Good. O is observation. Okay. R stands for?
Randomization.
Randomization of random selection of sample. That's it.
Sample. Yes, sir.
Excellent. Any other one? Okay, it's always better that you write your name. Okay, Oppo F1S it is showing. Okay, it's better that you write your name.
Okay, sir. Okay, thank you.
Okay, though attendance are not taken, but it would be better so that we can address you by your name. That's the only thing. Yeah, yeah, you're welcome. Can you any other one?
Static group comparison also completed, sir.
Yes, I know. Good. Other than Usha, anyone? Other than Swarup? Okay, they are very active. Okay, so any other one? So let me check with any other one whether they are able to understand or not. Jagdish. Okay, Karyappa.
Sir, yesterday's was little unclear. Could you just give a brief brush up, especially that randomization part, that part?
Okay, any other one? Naresh Kumar.
Sir, can you please repeat the question?
So what was yesterday's class?
Oh, okay.
Okay, a little bit about
sir, we learnt about approaches to experiment, that is true experimental, quasi-experimental and non-experimental.
Good. Okay, what is this non-experimental or pre-experimental designs? One short one.
It's a case study, sir. That's
okay, good. Okay, just you please refer to the page numbers. Okay, so we will start today with the true experimental designs. Okay, so what true experimental designs means?
One is with randomization, the other one is without randomization, right, sir?
Okay, when we're talking in terms of true experimental designs, the selection would be made on basis of randomization. Okay, the assignment would be randomly selected samples would be there. Okay, please write down first one, post test only equivalent group designs. Post test only equivalent group designs. Okay, when we say groups, how many groups we have?
Experimental group and non-experimental group.
Okay, experimental. Okay, then the other one is
control
group. Okay, good.
Control group.
Okay, you should not say non-experimental, but it's called as control group. Okay, they are saying equivalent group. So in what way they are getting equivalent? Because of randomization. You getting me?
Sir, can it be also called as balance group? Because we are balancing through.
Yeah, hold on. For example, in static group also we have two groups, but their randomization is missing. When it comes to two experimental designs, so we are assigning sample to the two groups, that is experimental and the control group, through randomization. Okay, what can be the best method of randomization for the knowledge of other people?
Lottery method.
Good. Lottery method. Okay.
Random from population.
Okay. For example, if I have 32 people as of now, so all 32 names would be written on that. You getting me? The first chit will go into the control group. The second chit will go into the experimental
group.
So I don't know who would be assigned to a control group and who would be assigned to experimental group. Did you get this? Randomization, what we call as simple lottery method, is one of the methods. Or if I have time, so I can write all the names. Okay, as I have written numbers, I can write the names also, the same procedure. Okay, so this is how I assign them to randomly to experimental group and the control groups, so that they get equivalent because they are randomly assigned. I don't know their names, their backgrounds, etc. So without any chance factors, so I have taken all the eligible people who can be into my population. From the population, I have selected them scientifically as a sample, and this sample of 32, I'm dividing them into equal groups of control and experimental group. If 32 have to be divided into half, how many?
16, sir.
16, sir.
Good. So randomly, without any order, without any bias, without having prior knowledge who would be into control and experimental groups. So I will have equal number, that is 16 into control group and 16 into experimental group. Okay, did you get this up to here?
Yes, sir. Yes.
Yeah, that is the reason they are saying equivalent group design. Done. And they're saying it's only post-test only. What is post-test?
After the experiment.
After the
Experiment, sir.
Experiment.
Experiment.
Yeah, is my screen visible to you all?
Yes, sir.
Yes, sir.
Yeah, just look at where are the observations made? Or
O1 and O2.
Good. If not, R stands for
Randomization.
randomly selected. Okay. X for
Variables.
okay, or the experimental.
Krishna.
Oh, who is that? Okay, experimental manipulation. Okay. Then I am making 0, 1. What is 0? Or what is O? Actually, O it is, not 0.
Observation.
Okay, do I have this X for the second group? Just think about. Just look at that. Is X limited to only one group or two groups?
Two groups.
One group.
It is limited
One
to
group,
one
sir.
group.
One group.
One group.
Only first group.
Okay, if it is first group having X, then what it is called as? That particular group is called as? If I introduce the experiment, that group becomes?
The first one is experimental and second one is control group.
Excellent.
Group, yeah.
Excellent. The first group is the experimental group. That is the reason I am introducing the desired experimental change, which I am interested to know. So X is introduced to one group. That is the first one. Okay. But you should remember, or you should look at the picture and say that before I'm not making any observations. It's after the introduction of the experimental manipulation or change, I am making an observation. Okay, that is the reason R, when R is written, before there are no observations made. Only after observations are made. So that is the reason we are calling it as post-test only. Is that okay? What is the post-test one?
First one, sir.
Yeah, first one. Yeah, up to here is it clear?
Yes, sir.
Post-test only. So before.
Sir,
Pre-test, no observations are made.
Sir, like in any experiment, it's called a scientific experiment only if these three parameters are there, no, sir? There has to be randomization, that is experimental variables and observation. These three have to be there, right?
Yes.
Otherwise, it's not called an experiment.
It's not exactly not like that.
It's not called as a true experiment.
True experiment. That's it. Excellent. Excellent. Okay, up to here it's clear. Just I was searching for the another slide. Okay. So what is this design called as?
Experimental design.
Yes, under two experimental designs. The first one is post-test only equivalent group design. Okay. So we are making observations at the end. That is post condition only. That is the reason it is called as post-test only. Can I remove this slide?
Yes, sir.
Okay, we are
Yes,
talking maybe page number 83. You can write down page number 83. It has been taken from there only. Okay, you need not worry. The same pictures I am trying to show you. Okay, done. So what is the other one? The second one. Okay, pre-test and post-test design. Yeah. For the knowledge of other people, what is the precondition? What is the post-condition? Yeah, what can be precondition? What can be the post-condition?
Before test it is
Before
pre, sir.
test or
Yeah.
before
After
experiment.
test it is
Before applying the variable for our test and then after applying.
Good. Okay, so before a experimental change is introduced, that is called precondition. So after the introduction of the experimental, okay, the change or the experiment, it is called as post condition.
Post condition.
Okay, so we are talking in terms of a true experimental designs. So they have randomization. Okay, so the second one is pre-test and post-test control group design. Okay, here it is clearly written. They are saying it's a control group design. So generally, how many groups we have?
4 groups.
3 groups. 3 groups.
Only 2 groups, always. Experimental and control.
Yeah, experimental and control. Okay. Now, what is the difference in this particular design? So this design is denoted by this particular way. So as we know,
Pre and post.
yeah, as we know,
First,
R stands for randomization. So
O
both,
for observation.
yeah, experimental group and control group are randomly assigned. That is the reason we calling them as equivalent groups. Okay. So now you can see we have observation 1 before the experiment or after the experiment.
Before the experiment.
So before, maybe before this class, I'm trying to take a test. So that becomes, okay, pre-score. I'm trying to introduce, okay, the experimental. Okay, let me take a pen kind of a thing. So after that, I'm trying to introduce a change. Is it to both the groups or one group? Okay, only one group.
One group.
Yeah, this one group will become, or what is this called as?
Experimental group.
Experimental
group.
Okay, I'm not able to write. Okay, experimental group, because experiment, for example, maybe a bridge course is introduced or a reward, as we talked yesterday.
sir here 1, 2, 3, 4. What is this, sir?
What is O? O stands for?
Observation.
O stand for observations.
Yeah. So before taking a psychology class, I have taken a test. Okay, that is called as observation 1.
Observation.
Okay. Then I have taken a class that is X. After that, again, I am trying to take another test that is called as observation 2. Okay. So when it comes to control group, so before also I am taking a test. Okay. After, okay, I am taking a test. The only thing is that here the class has been not taken. Okay.
Control.
So what is this called as?
Control.
Pre and post control group design.
Control group.
The previous one, only post test was done. Only O2 was taken. In this, both pre-test is also conducted and post-test is conducted. So whatever the difference may be because of
experimental.
Okay, the experimental, the control or the change or the program which I am trying to introduce to the experimental. For example, it can be a training session, or this can be like a our classroom lecture. So before and after, is there an improvement in their knowledge? So this can be checked. So up to here is clear?
Yes, sir.
First one was only post test. This is pre and post. You always remember that when they're saying observation. So that observation can be done in terms of a exam if it is related with our knowledge, learning, performance. Okay, or if it is a skill kind of thing. So what is the skill level before training session and maybe after attending a training session? So what is the improvement? So that can be assessed. Okay, and the next third one, the last one is the Solomon 4 group design. Please write down Solomon 4 group design. So this is the combination of both the 1 and 2 what we have discussed before. I repeat, Solomon 4 group design is the combination of the 1 and 2 what we have just discussed. Post test only, pre and post test design. Okay, and it is denoted by like this. Okay, I have taken the pictures from. Yes, is that visible now?
Yes, sir.
Okay, let me use a pencil.
Sir, which page number, sir, in the textbook, please?
84. You can write down 84.
Okay.
Yeah, so this is combination of two things. So what is the bottom one? Just please observe. Yeah, don't try to look at your textbooks, okay? You will be getting confused, okay? Just try to understand.
Pre-test and post-test control group.
Excellent. What is the down one? This one is?
Post-test random.
Post-test only. The first
equivalent group design.
Yeah, the first design what we have discussed is a post-test only. Because no observations are made here.
Yes, sir.
So no observation. So this is experimental group. Okay, no experiment is introduced. This is called as control
group. Group.
Excellent. Okay, so no observations are made before, but only after they are made. So this becomes my post test only.
Post test only.
Okay, post test only. Yeah, what is the upper one? This one.
Pre and post test.
Pre-test and post. Pre and post.
Pre and post test.
Control group design.
Okay, good. Okay. So what is this the upper one called as? What is this group called as? The upper one?
Experimental group.
Excellent. Experimental group because the experiment has been introduced. The down one?
Control group.
Control group. Okay. So in the experimental group or the above, so is it only post-test or pre-test and post-test?
Pre and post.
Pre and
Pre,
post, sir. Both, sir.
before
Both.
introducing of experiment, okay, I am also taking the readings. That is as simple as that. So before I start this class, if I'm trying to know at what level my student is.
Excuse me, sir.
Anulu?
Hey, hello. Is my voice audible now?
Yes, sir. Yes.
Yeah, there was a sudden power cut actually, so that is the reason I could not join. Yeah. So we were discussing the third one, which is called as Solomon full group method. So what is that method is about? Okay.
Combination of both post-test only, pre-test and post.
Good. So what is pre-test only and what is post-test only? I'm trying to open this slide. Yeah, what is pre-test only? What is post-test only? Pre and post-test.
No observations
In pre-test, sir.
Yeah, is this visible now?
Yes, sir.
Yes, sir. Yes.
So as you can see, so this is a combination of both the first method and the second method. Okay, the first method, that is post observations only. So these are the post observations only. So post test only. And when it comes to the upper part now, this is pre and post test conditions. Okay, yes, so this is very most advanced, and this is the combination of both 1 and 2 methods. Okay, so in this, the difference between these two.
Sir, what is the second one?
Post test.
Pre and post test.
Second one, post test only.
Yeah, as per our discussion, we talked first one, post test only. Okay, the second method what we talked is about
Pre and post. Pre-test and post-test.
Pre and post-test condition.
Post-test.
Okay. So this is my one, first what I discussed, post-test only. These are the one. Okay, the second technique what we talked about is the pre and post-test. Okay. So this is the combination of both 1 and 2. Okay. As you know, so it is more advanced. Okay, 1 better than 2. So when we're talking about the third one, that is the Solomon 4-group method, this is the combination of both 1 and 2. So very, very good or advanced method. Okay. So here I can try to know the difference between, just look at what is the difference between 2 and
4.
Okay, like this. Okay, 2 and 1.
2 and 1.
So this is one combination. Then 2, 4. Okay, 2 and 4. Okay, the last one. Okay, 5 and 6. 5 and 6. So without randomization, what is the difference? Just look at it. So without randomization, so how are the scores or what is the difference? Okay. So difference in the sense here we are introducing
experimental variable.
That there is randomization. The randomization is there. We cannot say that it is without. It is not a true experiment itself. If it is,
it's a true experiment, but only the post one. Okay.
Only the observation is missing, not the randomization, I believe.
Not randomization. Okay. So 5, 6, what is the difference? Okay, here I'm taking pre and the post test also. So this is also one difference I can find out. Okay. So again, this one, 2 and 4. So what is the difference? So this is how it's a combination of 3 things. Okay, here we can also try to find out, the other environmental factors, if there any influence of that. Okay, so with the difference of these 3 combinations, we can try to know what is the actual effect of the independent variable on the dependent variable. Okay, but you should remember that for conducting this particular group, so how many groups should I need?
4 groups. 4 groups.
Okay, good, excellent. 4 groups. 1, 2, 3, and 4 groups. Okay, 4 groups has to be there, and this is a true experiment, so we need to equalize them. So we need to randomly assign them. Okay, all that thing has to be done, and you should always remember that as the number of people are, as the group is increasing, the more number of sample we need to have. Okay, and also when you start doing research, especially if it is a one-time experiment of a kind of a thing, okay, no problem. But when we're talking in terms of a research, so research is done over a period of time. So over a period of time, there is no guarantee that, okay, so whoever is into one particular group, like for example, maybe first group, so some of them may drop because of n number of reasons. So there is no guarantee that till the end of the experimentation, I have all the participants in each group. You getting me? So in between, in experiments, I cannot add people. Because in most of the conditions, for example, pre and post is there. So whenever there is pre and post, so I am checking them for 2 times. You getting me?
Pre and post.
Yeah. When I said it's a one class, maybe I am talking about 1 hour. But for example, if it is a sessions, series of lectures, series of activities over a period of time, so sometimes there is no guarantee that all the people would be with me. Especially when you talk in terms of a research, so long time, 2 to 3 years, 4 years.
Same examples. From morning to evening, these classes are going.
Okay,
those are there in your class may not be there in the last class.
Okay. Okay, so this is how over a period of time, so there is no guarantee. So I should have a large number of sample to have 4 groups. Okay, and also returning them or to have them till the end of the experiment is the other. Okay, the problem or disadvantage with this particular group, and as well as the analysis also would be becoming lengthy. Okay, I'm repeating, analysis in terms of difference between 1, 2, 2, 4, then again 5, 6. So this is how calculations would be increasing. So if I have few number of sample, it's okay. But when we're talking in hundreds of sample, so this is how calculations are also getting a little bit confusing.
Sir, excuse me.
And
sir,
yes, go ahead.
Sir, why we are taking 1, 2, and 2, 4, and 5, 6?
Yeah, this is advantage of this particular group, no?
Then what about 3 and 4? 3. Why we are not taking 3?
What is the difference in 3 and 4?
This variable is not there.
Control group, no?
Control group, sir.
That is a control group, no?
Control group. Then
yes.
How we are taking 2 and 4?
Control group, we are not using the experimental variable, no, sir.
Okay.
Hello.
For example,
for pre and post test, after the pre-test, the sir is taking the class, again he is giving the post test in the experimental.
That is.
But in control group,
the
just hold on.
Is not there, no, sir.
Just hold on. I will tell you. I will tell you. Don't worry. Don't worry. What is 1?
Experimental.
Experimental before.
Experimental before.
Before.
0, 2 is experimental after.
After.
Yes.
Okay. So if I take the difference between 1 and 2, what I'm trying.
Sir, experimental group or.
Yeah. Okay. Just hold on. Just hold on. Okay. Let me tell, because I'm not able to see your. Yeah, like who is talking also, because I'm screen sharing. No, I don't be having that facility. Okay. So difference of 1 and 2 is going to give you the effect of.
The effect of
variable.
Okay. Not variable.
Variable.
The experimental effect, it's going to give you. Okay. So before experiment, what is the score? After experiment, what is the score? Will I compare to 2 and 4?
Yeah.
I'm taking the post only.
Yes, sir.
Okay, the final scores I'm talking. So with experiment, what is the final score? Without the exposure, what is the final
score?
Okay, now also talking about 5 Okay, 5, 6. Yeah, 5, 6. As you know, for 5 there is a
experimental
exposure, and 6 there is no experimental exposure. Okay, so this is how you try to look at. That is the reason they are not checking 3, 4, but they're trying to look at 2, 4. So with experiment, what is the score? Without experiment or without exposure, what is the score? Okay, so it's in the page number 84. Okay, you try to just go through that, and you take as our example, okay, the smallest or the simplest experiment, like having a brief introduction to psychology. So before and after. Okay, so how is it going to have impact on your knowledge or awareness of psychology subject? Okay, you try to simplify first. Okay, and try to look at just, you will understand this particular concept. Okay, so before that, first you try to understand the one post test only, then pre and post test. This is a combination, or this gives all. After post, only post test, what is the difference? Okay, pre and post, and all the combinations it is going to give. Okay, up to here it's clear.
Okay, sir.
Okay, then the other concept is about the experimental designs only.
Sir, one question.
Go ahead. We don't have time. Go ahead.
We have 3 true experimental designs, right? Post-test only, pre-post-test, and so on. So basically, the effectiveness of these 3 tests will be in that order. Like the last one, the Solomon 4, will be more effective and more truthful regarding the validity.
Yes.
So the first one will have the minimal. But can you just tell me what would be the real world application of where exactly these 3 types of experiment would be used?
Excellent. So 1 is preferred, okay, when you want just only post scores, as I said yesterday also. So experimentally, we try to go with the second one, pre and post conditions. Okay, pre and post is the most used one. The second one. Third one, very rarely used. And they don't encourage
because of its complexity. Yes.
Because of its complexity. Okay, and also especially having 4 groups of sample.
Yes. Yeah.
Okay, getting sample, especially with regard to some specific characteristics. For example, autistic child, okay, mentally retarded child kind of thing. So where the availability is very less, and if you want to go with the 4 groups, it becomes highly impossible.
Yes, I understood that conceptually, but I was looking for the real world applications. Where exactly? Like yesterday when I asked you.
Second one is most used in the research part. Okay, third one rarely used. Okay, first one is not preferred. So second one is preferred. Because there I have before and after also. Okay, up to it's clear? Okay,
yes.
Then we have experimental designs 1, that is unit 10. So this particular topic.
Sir, is this experiments only used in the clinical observations of the patient?
No, yaar. Why are you talking about only clinical? I have taken an example.
Sir, diagnosis test is example of.
We are not talking about diagnosis. Education. We are talking about research. Yeah, these researches are
asking real life example. Sir.
Yeah, real life. We are talking about research.
Before admission,
clinical diagnosis is different. Clinical diagnosis is different. For example, if someone have come up with a new strategy with regard to one particular disorder, and they would like to check out. For example, maybe like the meditation is going on, yoga and meditation. If someone have come up with that particular concept saying, maybe subjecting them to yoga and meditation would be better, especially with regard to one specific psychological disorder. So that time they can have one group getting exposed to yoga and meditation, the other group they don't getting exposed or having this particular meditation classes, etc. Okay, I'm trying to look at that particular thing. Okay, yoga and meditation and its effect. But I'm not talking about diagnosis of that particular psychological disorder. So diagnosis is different. So when you're talking about diagnosis and all that, okay, you are referring to clinical psychology or abnormal psychology. Is that clear? So
Yes,
clinical,
sir. Got it, sir. It's clear now. Yeah.
Clinical abnormal psychology talks about the classification, characteristics, and how you diagnose psychological disorders. So research part, we're trying to look at other strategies and all that. Okay, if you think that this particular strategy can be of some use, so that time you can use one group, you can give this particular strategy, other group without strategy, and you can check whether this particular strategy, what you're thinking to be effective, is really effective or not. So for that, it's always better that you have two groups, control group and experimental group. And it's always preferred that you take precondition before score, what is the score, and maybe after, so that the difference can be taken as only because of the strategy what you have introduced. So this is how you try to know the effectiveness of strategies or training programs, etc. So these are very much generally used in education, that is learning and or psychological settings. Okay, not clinical settings. Okay, you please do remember that. Okay, clinical psychology different, and this research part. This research, as I said in the first class, maybe you all are missing this particular first classes. So research methodology would be for all the subjects, all PG subjects. They have this research methodology. The only thing is that their methods would be different. Telugu people, their methodology would be different, or basic behavioral sciences. So we do it in a different. They also have independent. They also have dependent variables. Okay, the way we look at it is different. Okay, Swati, go ahead.
A small question, sir. Meer cheppina example, based on the example that you've given, a group of students and their scores before and after a control experiment. Ippudu R03 is pre-test in the last case, or in any case, R03 is pre-test for a control variable, for a control group.
Let me check. If you tell that, no, I don't understand.
Okay, sir, no problem.
Because parallelly certain things are running, no? So we cannot tell that, okay? Observation 3.
Right. Observation 3, RO3. This will be the pre-test for control group.
Obviously, right?
They are not given any external control. They are not given anything. Ante bridge codes lantidi you're not giving any them, and they are writing a post-test. And that observation is O4.
Oh, that's it.
If they're not given any external push or bridge codes, their answers for R03 and 04 would be same. There wouldn't be any difference, right?
Yes, but I should have a group score for comparison, no? 02 and 04 I should compare, no? This is not assumption, no?
Okay, makes sense. And what if
we are talking in terms of a scientific methodology, so you should have a score showing, okay, 3 and 4 are same compared to the other things. Yeah. Go ahead.
And what if we give a fake bridge course? For example, you give the correct bridge course to the original experimental group, but you give a fake bridge course that is not related to the test. And you take a scores after that, O4.
Yeah, that can also be training course 1 and training course 2, no?
Right. Now, how do you represent that fake bridge course in this picture?
Yeah. Stop using false bridge course, okay? Here the intention is only, so what the effect of a training course or a bridge course with and without a bridge course. Okay? Maybe you talking about placebo effect, that they do it in pharmacy, drugs, etc.
Okay, right.
Yes, you talking about something, okay? Especially that is used in drugs. They give a placebo effect, they call it as, okay? They give a sugar coated thing.
Okay.
A sugar syrup or a sugar, the tablet kind of a thing, and they try to give the actual medicine. Okay, and just they would like to see whether that feeling of taking a medicine have any effect. You getting me?
Yes, exactly.
It's not a medicine, but do they have this particular feeling that when they take medicine only, they have this particular healing, etc. They can come out of that. Okay, that's called placebo effect.
They remember well to write the test, something like that.
Yes, that is called placebo effect. Okay? That is.
So we do not represent those variables here.
That is different conditions.
Okay. And what about extraneous conditions? Like, for example, pre-test and post-test, the questions will be same. Will that not affect them? Why don't we represent extraneous variables that can impact these conditions here?
No, you're completely messing up. What's your name? You attending from?
2 days.
Only on 2 days. That is the reason. Okay, don't mess up. Don't confuse others.
Okay.
Okay. So if I take a pre-test, for example, before this class, the questions would be different. And maybe after introducing, I try to take the different questions but I'm trying to look at how much knowledge or how much awareness they have.
Okay.
Can you define psychology? Maybe initially they would have not able to tell, but if I ask them, they would be able to tell, no?
The question is same, define psychology, pre-test and post-test.
Yes. Likewise, it doesn't mean that I ask the same questions. I'm looking at the knowledge, skill.
Okay.
Okay, it's only to ascertain at what level they are.
Okay.
And especially with regard to maybe if it is some specific training, so specific scores before training, how much they have and how much improvement they have with regard to that specific skill, okay, after training. So that can also be done.
Okay.
Okay, so this is how it happens. Chalo. Then we will get back to unit 10. It's talking about experimental designs. So this experimental designs, as we know, as we have read before also, but in this, it can be termed as between group designs and within group designs. Okay, so experimental designs can also be in terms of, okay, between group designs and within group designs. Okay, what is between?
Between means two groups are taken.
Excellent, 2 groups, that's it. What can be the 2 groups?
Whatever the whatever the experiment we are going taking, experimental group and control group.
Excellent. Control group and experimental group. Okay, so they are trying to tell you in terms of between group designs. That is the only difference.
Okay, sir.
So between is 2 groups.
2 types, control and experiment.
Yeah. Within group design.
Only one group. Either it may be experimental group or a control group.
Control group.
Okay, within is, okay, 1 group or same set of sample. Please remember, same set of sample. They have tested, okay, 2 times. As we talked about, okay, pre and
post
kind. Okay, within is the same group, same set of sample. When it comes to between group is
2 types.
2.
Different set of sample.
Okay, you should not get confused. Between groups, whenever you have a group concept, that is always they're talking about the independent and
dependent variable.
Dependent variable. Up to here is clear? Did I make it clear? Please do remember that between
is 2.
Okay, different groups. That different groups can be my, again, control and experimental groups. Control group is the group which is, okay, not subjected or not got exposed to any experimental condition. Experimental group is the group to which I am introducing, okay, my research or my experimental changes. Okay, so with experimental exposure and without experimental exposure or without introduction of the experimental, okay, that particular manipulation or treatment or what they call it as simple terms as a program.
Control group.
Okay, experimental program, experimental exposure, and you can take as a synonym. Within is the same set. Oh, use that. Okay, so within is the group where they're getting exposed repeated times. That is pre-condition and post-condition. Yeah, up to here any confusion? Up to it's clear?
Yes, sir.
Please do remember, between is between two groups. Okay, within is the same group getting exposed to different experimental conditions. Okay, now the question is that, so which one is better in comparison to both, between groups and within groups?
Sir, it depends on the experiment, sir, research.
Yes. For example, we will talk in terms of sample. So getting sample would be more for which particular group or which particular type?
Sir, between groups design, sir.
Excellent. Okay, in terms of sample, yes.
We can compare how it is effective.
Yes. We will talk particularly in terms of sample first. Okay. So more number of sample is required for which particular type?
Between groups.
Between groups. Okay. So because different set of sample has to be there for control group and experimental group. Okay. What about within group?
Only one sample.
Yeah, only one set of people because they are taken repeatedly. Yeah, that is with regard to sample. Okay. Then when we talk in terms of, okay, getting the genuine results or the true results. So which can give me the more genuine results? Or in terms of like experimental exposure, which particular groups of types can be taken, okay, for getting the actual difference of the independent and dependent variables?
Between, sir.
Between groups.
What happens within group?
Within groups, there will be a limited variables are dependent or independent variables. Between means there will be more.
Within group.
And the effectiveness also cannot be measured, sir.
Yes, good.
Yes, sir.
Good. For example, with regard to practice, if a person has to do a task repeatedly, so when they're doing it for the actual condition, experimental condition would be better. Or, for example, if within the same person doing it repeatedly, is that going to give an edge, advantage?
No, sir.
Or disadvantage?
Disadvantage.
If it is with regard to do a task, if the person is doing task for a double time, will the scores would be better second time?
Better, sir.
Better, sir.
Better,
Yes.
sir.
Yes.
His advantage.
Better. Okay, you getting me?
Yeah.
So with regard to practice, okay, within group, when they do it for the repeated times, okay, as they're doing it under different, okay, pre and post condition, post results can be better because already they would have got practice. You agree with this?
Yes.
Yes, sir. Yes, sir.
Okay, with regard to fatigue, for example. So which particular group would be experiencing more fatigue? Between or within?
Between group.
Fatigue, physical fatigue, tiredness.
Yeah, it's I think in within only because they have to do the experiments repeatedly to get the results. The fatigue will be more in within.
Okay, just remember within.
Energy will last, no, sir.
Yes, if they are doing it for
number of times.
Yeah, repeatedly.
Repeated.
For example, like my same set of students sitting from 10:30 to.
Yes, sir. Reverse, the case will be reversed.
When it comes to practice, okay, the more they are practicing, the more scores can be. Sunita is buying something. Okay. Sunita, we are listening everything.
What iPhone users.
What are they buying actually?
I think you would be able to mute them, sir. Like
yes, I can do that. Yeah. So with some regards, for example, practice, that will give an advantage. When it comes to fatigue kind of a thing, okay, more fatigue can be experienced within because they are repeatedly doing certain tasks. Because the same set of people they are doing different activities. Okay, so physical fatigue can be there. So this is how. So between and within groups, they have their own advantages as well as the disadvantages.
Which is better?
Yes, sir. Yes, sir.
You getting me? Advantage is that okay, less number of samples required. Okay, so when different groups know certain, like for example, the individual differences, okay, their prior knowledge. So there are certain types of things which we cannot control. So as different set of people,
maybe completely depends on the research what we are doing.
Okay, so when different individuals know different individual differences can have effect, etc. But when I'm talking in terms of within group or the same group, no, the same person would be in the condition 1, condition 2. So individual differences or the personal traits, characteristics are nullified or they remain same in condition 1 and condition 2. You getting me? So they have their own advantages and
disadvantages.
Okay, same person doing repeatedly the physical fatigue, etc. So it will definitely have impact on the actual performance. Even if it is writing a test, also they can experience that. You agree? Doesn't mean that doing a task, physical task, but even if they have to attempt a question answer kind of a thing, or if they have to do even a paper pencil type of a test also, they can have this particular effect of fatigue. You agree?
Yes, sir. The same thing, sir. You already said taken the classes, but now you are not interested to repeat the same. So this will be also taken, sir.
You don't take that as a serious example.
No, sir. Yes, sir.
Remember that, sir.
To make you aware and to make you get into the experimental setup, because you're already experiencing that. You getting me? If I tell some example out of the context, no, you don't understand. So when you are into the context and if you're trying to refer to that, okay, this is a more understanding or more comprehension. So that is the reason I have taken this particular experiment, and I'm saying, okay, if the same set of people, they have to get exposed to different conditions, experimental conditions. So this is how there can be fatigue, tiredness, okay, carryover effect also. Okay, carryover effect in terms of practice can be advantage. Okay, they cannot do the task 1 maybe, so that carryover effect will have effect on the task 2 also. Okay, so this is how advantages and disadvantages would be there. Okay, and we are particularly looking at between group designs. Okay, so between group designs, there are 3 types of designs. Okay, and they are very simple, our continuation of what we have discussed before. Okay, first one, please write down simple randomized or 2 randomized group designs. Please write down simple randomized, or you can refer to page 87 after this class. Okay, 2 randomized group designs. So what are the 2 groups?
Between group and within group.
Oh, there are types. When I say in terms of groups,
experimental group and control group.
Control group and experimental groups. Okay, don't get confused. Okay, types. Okay, experimental types is between group and within group. When we talk in terms of groups, 2 groups. Okay, 2 groups can be experimental group and
control group.
Okay, and it is very simple and clear also. We have 2 randomized groups. So randomly selected 2 groups So that two groups are, one is experimental and other one is the control group.
Control group.
Clear up to here?
Yes.
Yes, sir. Yes.
We're talking about true experiments where we have two groups, control and
Experimental
group. Okay. The second type is more than two randomized group design.
Say 3 will come.
Obviously. 3 are more than 3.
No.
Okay. So they're also randomized groups.
Group designs.
Okay. In simple terms, if I have to check different drugs or medicine A, medicine B, and medicine
C.
In the first condition, I can only check whether A and B are effective. Here I can check more than 2, that is A, B, and C. Okay? Try to understand in a very simple manner. So once you understand, so whatever example you feel like giving, no, just you can explain in your own terms. Or a teaching method. Teaching method 1, 2, and 3. The conventional classroom teaching method. Second one, what we have, this particular online class. Third, if I'm interested, is it good or effective to combine both? Okay. Combine both, okay. So classroom teaching with help of online, okay, demonstrations, etc. Or in simple terms, what teachers called as using multimedia or ICT. Okay, ICT in teaching. Pushpalata, I will mute you. Okay, classroom teaching is best, sir, with some animations on board. Okay, good, excellent. Okay, that is known to us. Okay, this is a known example to us because we are into this particular learning, and as we know that, okay, only a classroom teaching, or if it is online, so if it's a combination of both, which can be better, because we're part of that. But maybe if scientists, they are talking in terms of drugs A, B, they can go for 2 randomized group design, or if they have any other one also, so they can check it out using this more than 2 randomized group designs. Okay, whether A is better than B or B is better than C, or A is better than C. Okay, so this is how different things can be calculated. So up to here, any doubts? So between group designs, they have 2 groups, that is control and the experimental group. They are selected randomly. So it's called as simple randomized 2 group design. If I'm muting, you know, don't unmute, no. Yeah, in 2 randomized groups, we can check, okay, in terms of, okay, experimental and control group. If it is more than 2, no, rather than checking only 2 things, I can also add up more and more. I can check, for example, as I said, in the teaching method. So this is more than 2 randomized group designs.
Sir, okay. I have a doubt.
The third one, go ahead.
Sir, in the 2 group method, one is control and one is experimental.
Yes.
Whereas in the multiple group, will there be a control group or all are experimental?
Yeah, the control group can be, for example, my conventional teaching methodology. You getting me?
Okay, that will be the control.
Yes. The regular teaching method. For that, I'm adding another 2 methods.
Okay.
Yeah, simple. Good. Okay, then the third one, matched group designs. Please write down third one. Matched group design. So I am trying to match the groups before I conduct the actual experiment. So matching. So how do you match, or what does it mean by matching? So matching can be done at the level of individuals or at the group level. For example, so for matching, I have to take one particular criteria. Based on intelligence, if I'm trying to match them. Okay. If I say, if I'm matching them on intelligence, what should I have? Their intelligence scores should be with me. Okay. So this is how, when we move down, the methods would be a little bit of complicated. So before I conduct experiment, so I have to conduct a test. If it is about intelligence, I need to conduct intelligence test. I should have intelligence scores. Then I am trying to match them. For example, if I have intellectual scores or intelligence scores, IQ levels, so I will pick them as a pair. One IQ person with 90 and 90 I should have. So 190 would be randomly going to the control group. The other one would be going to experimental group.
I mean, is this process of randomization itself,
yes,
or?
Yes. Hold on. Don't jump. That's what I said. You should randomly assign them to experimental and control group. So we are trying to match them on IQ levels. So when you pick a pair, so there you randomly sending them to control and the experimental groups. Okay. Now you ask the question.
My question was like, I mean, is this the process of randomizing itself, or we are doing the matching after picking the random groups, or after randomizing them?
You should have this course first, and you should select the pairs, because one has to go into independent, one has to go into the experimental group and the control group. Okay, that's what I said. When you try to assign them to control and experimental group, you try to do randomization there.
Sir, it means we
okay,
have
so
to
we'll do the
matching
first, then randomization
yes,
later.
Yes.
Got it, sir.
Because you don't have many people on one particular IQ levels. Okay,
Got
first you try to pick them.
Yes.
Then you try to assign them randomly. Random selection, you should always remember. Yes, someone was talking. Usha?
Sir, first we have to take sample with same IQ level persons, no, sir. That time only, then we pick them. मतलब first group को हम assign कर सकते हैं, second
You
group
listen
को
first. You listen. What I said. Before I should conduct a test, then I have a scores. I should pick them as pairs. Okay, if I told the example also. If I have two people with score 90, okay, I'm picking them as one pair, and I'm sending 190 randomly to experimental group. The other one will go into the control group. Okay, up to here is clear?
Yes.
So it's looking very, very, very good that you're picking them pairs, you sending randomly to one group, another group. But is it always guaranteed that how many people you get on same scores? Possibility, any possibility?
Can you repeat the question, please?
Will I be able to get more people on same IQ levels? Maybe not possible.
Yeah.
No. Because if I have any one person with 93 maybe high school, and if I don't find the same IQ person, then this particular person whom I have 93 would be of no use to me, because I should be matching this particular 93 in the other group also. So on how many people I should select? Now, how many people I should conduct this experiment? From there, I need to pick this particular pairs, etc. So very, very, very laborious, lengthy procedure. I need to have a large population. I need to conduct, for example, like IQ. And from that, I need to pick the pairs. And getting same equal pair becomes difficult most of the time. If I have one person with one score, no, if I don't find the same other score as a pair, it won't be of any use. You getting me? So very much of time taking procedure. Okay, so it can be used with small or limited groups. Okay, but we always, or we talked before also, it's better that you have a large number of samples. Okay, so as the less number of samples, the results may not be generalized. So to have more generalizability, you should always have more and more of sample. So in this particular method, matching, so you need to start with a very large number of population. From that, you need to pick the matches and you need to assign them randomly to experimental and control groups. Then after that, what the experimental program, so that you should introduce to them, and that time you can have this pre and post scores and you can have a comparison of that, and this is how you arrive at. So what is the effectiveness of this particular experimental program or condition you have introduced? So this is matched group design. So if you have same number of scores in experimental and control group, so if I take the average of the control group and experimental group, there will be equal. Okay, so this is how two groups are matched. Then after that, the actual experimental procedure would be cut. So this is, so addition to your actual experimental changes or introduction of program, so lot of work has to be done before in terms of matching. And also sample has to be required, very, very large number of samples. And you should be able to conduct the test and all that. If something goes wrong, no, when you get wrong scores and if you start matching people on wrong scores also, that can lead to a error. So care has to be taken at each and every level, and this is how matched group design is not very much used. Okay, up to here, any clear? Is it clear or any clarifications?
While selecting the population itself, we will try to match some criteria, right? So the population itself will be based on a specific criteria. No?
So we have discussed before only. So population, whoever is eligible, they would be called into my population. If I am saying as government 10th class students, whoever is studying in government school and whoever is into 10th class, if she is a girl, she becomes my population. From that, I need to match them.
So this is a further filtration within.
Yes. That's what I'm trying to tell from that point. So getting population, very simple. If they have these minimum required conditions met, no, I can include them into population. After that, I need to do all these things. And once I'm done with matching, no, after that, the actual experimentation has to be done. You getting me? Was it clear? So yes, I have population, but it doesn't mean that all would be having same IQ. You agree with that?
I agree with that, but I'm wondering whether this will have, this will have a huge impact on the generalizability. Like, because if you further drill down or if you further filter down the sample based on some matching criteria, how can I apply this particular results to the overall population, which is nothing but the generalization, I believe.
Yes, generalization, but this is a matched group technique. We are only talking about these particular intellectual people only.
So, so that is what, sir, my concern is when we do this, when we do the experiment.
If that is your concern, no, you should go with randomized group designs only. So based on the purpose, that time I will go with randomized group designs only. Where if I am thinking of generalizing.
So this
if I'm talking about how effective it is going to be with one particular IQ level, okay, then only I'm going with this particular matched group technique. So it's always with the researcher. So which particular technique you need to select based on the purpose or the object of his research design. So if you have matched group design, it doesn't mean that you should pick that particular group.
No, I'm asking whether this will be an effective method for the research design or not, because I mean, in my understanding, I mean, whatever.
Don't get confused. If you have to talk about, okay, in terms of generalization, okay, you can go with two randomized. So this is particularly talking about one selected group in terms of IQ levels. Okay, and the other continuation of this one, it's already 12. So difference between randomized or matched group technique. So which one is better? As we're talking, okay, randomized group design is better in terms of sample. So, yeah, getting sample for matched group, as I said, is very, very difficult. So randomized group design easily you can conduct. When it comes to matched group technique, okay, very laborious and time taking. So a lot of things has to be done before. So which one can be preferred? Randomized group or matched group?
Randomized group.
Randomized group. Okay, so that is with unit 10 experimental designs 1. Okay, so you try to please read this. Okay, you will understand better. So simple randomizer 2, randomized groups, we have 2 randomized groups, experimental and control group. When you want to have more than 2, it becomes more than 2 randomized group designs. And if you want to match them on one particular criteria or one particular quality, like I said, intelligence. So it's a further extension of that. So you can try to match them on intelligence so that both the groups are equal. And if you try to give them any experimental exposure, with confidence, you can tell that because the two groups being equal on all the respects, I'm saying all, with regard to match. And whatever the changes would be there, that is only because of what experimental program you have introduced or changes you have introduced. Okay, so this is with regard to experimental designs 1. Okay, see you in the next class. So when would be the next class?
One last question.
Yeah, go ahead.
So this is purely academical and exam related. So there are a lot of formulae in this particular chapter. I mean, are they relevant for our examination?
Sums will not be asked. This is not a statistics paper. Okay, first one that. Okay, second one, no. When you do the actual research, no, we have softwares for that. As we have Excel tabs, no. In that you can select this particular experiment, this particular type of experiments, and if you have this particular data, no, they will give you the final result. So that is the reason we are not talking about the calculations part. Okay.
Okay.
Done. So this is not stats paper. You remember that. In statistics, they will ask you about doing sums. Okay. Here they don't ask you about doing the sums. Okay, guys. See you all. Because it's already maybe 12.
Thank you, sir.
Okay, maybe the other
class.
Thank you,
sir.
Thank you, sir.
Hello. See you all in the next class. Okay. Please try to read the first units. You try to understand. Okay.
Yes, sir.
Chalo, see you all.
Thank you, sir.
Thank you, sir.